homework problem is one of the tutorials, plus or minus the Heisenberg uncertainty principle. Quick note, the numbers are going to be different for every individual out there. Your femtograms, your velocity, and your uncertainty. Those are all going to be a little bit different for everybody out there. So just a heads up on that. So I would recommend pausing me potentially and copying this down so that when you're working this with me, you're working off the same numbers that I am. Alright, I'm giving you a second to pause. Alright, I hope you took advantage of that second to pause. So let's actually take a look at working it now. This is really a straightforward plug and chug into the Heisenberg uncertainty principle. And we know, according to the Heisenberg uncertainty principle, the uncertainty in position times the uncertainty in momentum will be greater than or equal to Planck's constant divided by 4 pi. The formula looks very, very simple on its face, but you have to remember there are several pitfalls to it. First and foremost is the units. Your uncertainty in position is going to be in meters. Second, what is momentum? If you haven't had physics in a while, you may have forgotten momentum is mass times velocity. And mass, according to the SI system, has to be in kilograms. And I find when I'm helping students with the homework, that's usually the number one mistake people make, is they have that in something other than kilograms. Then we have velocity, and velocity has to be in meters per second. The other thing that throws people is this term right here is uncertainty, not the actual momentum. So let's go ahead and execute that. Nope, it's still keeping everything together for me. That's kind of nice. So we've got, let's focus in on one term here actually. Let's focus in, since we're wanting to solve for our uncertainty in position, let's focus in on the other terms. We know what Planck's constant is. We know what our 4 pi is. We know Planck's constant is 6.626 times 10 to the negative 34th joules seconds. And we know what pi is. Our calculator should have a button for it, right? And then we know what the number 4 is. And we're solving for our change in position, or our uncertainty in position. So what we're really needing to focus on is our uncertainty in momentum. Momentum is mass times velocity. And if you look at what they gave us here in the problem, they told us that we have 0.2 femtograms. Well, I said right here that mass has to be in kilograms. So we're going to have to do a quick unit conversion. So let's do a quick unit conversion here. 0.200 femtograms times 1 femtogram, 10 to the negative 15th grams, times 10 to the 3rd grams to 1 kilogram. That's going to give me negative 18 plus negative 1 is going to give me 2.00 times 10 to the negative 19th kilograms. So that's the first thing you have to make sure that you do, is that you convert to kilograms there. I hope you're following along on your own paper, right? So as I shrink or grow things. It's not panicking you because you've got down on a piece of paper in front of you. They've given me a velocity. So let's see here. We've got 2.00 times 10 to the negative 19th kilograms times a velocity that they gave me in the problem. Once again, they've given me non-conforming units for my problem here. They've given me 6 micrometers per second. So I'm going to have to do another unit conversion. Right? Non-conforming units right there. So let's do another quick unit conversion here. I've got 6 micrometers over 1 second. I want to get rid of micrometers. I want to go to meters. So 6.00 times 10 to the negative 6 meters per second. So now I have conforming units to use in my equation. So I'm going to shrink that up here. What I have right there is actually, oops, don't want to do that. Cooperate. What I have there in front of me right now, that term, where I have my mass times my velocity, that's momentum, not uncertainty in momentum. This is the actual momentum. So my actual momentum for my little bacteria here would be, it's going to be 1.2 times 10 to the negative 24th, I believe. Checking it on my calculator just to make sure. 25th. How did I get to the 25th? Because, and I'm multiplying, so it should go out, sorry, just a second, because 6 times 2 is 12, 19 plus negative 6 is 25, so why doesn't it go out to, oh, I know why. Dirty, dirty, dirt. No, I was right. I punched something into my calculator wrong. My brain is better than a calculator. And that gives me my momentum. But that's my actual momentum. Remember, the formula calls for uncertainty in momentum. If we go back to that original problem, I'm going to leave that number kind of large. Whoops. Well, I guess I have to shrink or just a second. Clean up on aisle 3, please. Clean up on aisle 3. All right. If I grow this again and we go back to that original problem, it tells me that I have an uncertainty in my velocity of 7%. I have an uncertainty in my velocity of 7%. Because mass times velocity is momentum, that means I have an uncertainty in my momentum also of 7% because of that uncertainty in velocity. If I wanted to, I could have calculated, I could have accounted for that uncertainty in velocity right here in this step, and I could have said How do you take 7% of something? 0.7, right? I could have accounted for it there. What I'm going to do is I'm going to, and that way I'm, see, and that would be my uncertainty and velocity. But I'm going to account for that uncertainty and velocity here really in the last step, where I calculate for that uncertainty and momentum. So now I'm correcting for my uncertainty. And I know for a fact from working with other students and in my face-to-face classes that everybody has at least a different percent. So the uncertainty in momentum is now 8.4 times 10 to the negative 26. And now I have the unit, or the number, that I can plug into my Heisenberg uncertainty question, my Heisenberg uncertainty formula. I'm getting ready to make a lot of things disappear here because this has gotten terribly messy, so I hope you've written this down. All right. Did a little bit of a cleanup here. Now we're actually ready to plug into our formula. So let's do that. And that gives me, when I go to my calculator, 6.626 second EE negative 34 divide by 4 divide by pi divide by 8.4 second EE negative 26, and I get 6.28 times 10 to the negative 10th. And that's your answer. Beep.